Here, today we are presenting a research project on data cleaning and crowdsourcing, history and applied approaches. My name is Rohini and presenting along with me Eric, Nick and David. We will be covering the introduction to data cleaning and crowdsourced data. Then we will be covering the research paper analysis and the conclusion. So lastly we will be referring the papers that we have referred. For any application that manages the large quantities of data, it is important to manage that data that has to be utilized and which should be in a proper, clean manner. The first step is usually using the data cleaning and transformation to shape the data so that we can use it productively. So, however, a technology has improved, the volume of data that needs to be processed has increased due to the increasing demand. So, the data cleaning came up into the picture. Data cleaning is the process of fixing or removing the incorrect or corrupted data or the incomplete data within the dataset. It is the process of cleaning the data for better results and the recovery. When combining the multiple data sources, there are many opportunities for data to be duplicated or mislabeled. There are the benefits of data to be clean because it eliminates the error, it eliminates the redundancy and also increase the data reliability. It also ensures the consistency and completeness. The benefits that includes the data cleaning that enhance the data quality, which increase the productivity, that boosts the results and revenue. So these are the all benefits that one should have while using the big data sets. Since the field of data cleaning and data transformation is extremely relevant in many present applications, we decided to perform a literature review to explore the research that is currently being performed. While carrying out this survey, there are some key objectives that we will be exploring. In this literature review, we will be researching the research paper data sets by both keywords and with the help of data cleaning and crowdsourcing. We will be covering compare the data cleaning techniques from before and the present day methods to find out which are the favorable for crowdsourced data. The first step will be getting the data ready to be the processed by a system or the application before doing any kind of meaningful processing of data. It is needs to be clean to a form that can be queued and compare. It is a process of finding and removing the corrupted and inaccurate records from the record sets. So we have done the couple of research paper review for our project in this domain. So moving ahead to the research paper analysis. Here, according to the author Monge, in this paper, the matching algorithm within the duplicate detection system, they emphasizes the identifying the database records that are approximate duplicates but are not exactly duplicates, which is the very important task. For example, one database may store the first name and the last name of a person like Jane Doe, while the other database may store the initials and the last name of the person like JB and Do. These duplicates concerns the same real world entity due to the data entry errors and standardization problems. So here in this paper, they have discussed the system to detect the duplicate database records, which are the two steps they have provided. First is the standard duplicate detection, which is means the standard duplicate detection of the detecting exact, which will detect the exact duplicates in a table, is to sort the table and then check if consecutive records are identical or not. If the exact duplicates are not guaranteed to be the next each other in the sorted order but can be found nearby. Second will be an adaptive and efficient duplicate detection system. Here, the author proposed how to compute the transitive closure of each duplicate of relationship incrementally by using the union find data structure. Operations where Ri and the will be compared with the union of the Ri using the matching algorithm technique. This research contributed to the existing algorithms for detecting duplicates. of records by introducing an integrated framework which draws from the existing algorithm. This research was able to measure the effectiveness of the developed algorithm against the standard algorithms. However, with very minimum interactions. It is also identified that the minimum interaction could result in an inability to identify the duplicate records. Next, as per the as per the author in this paper, that open user involvement in data cleaning or data warehouse quality. So here they have proposed a framework which works for a small amount of data being propagated and was not tested for large data sets. Their result extended the data cleaning and extra transformed load, that is ETL, process to better support the user involvement in data quality management. It has a user interface, is graphical, and hence to be operated by the end user. The graphical user interface which will be the easier to use by the end users. Then the data warehouse that was used for the texting of the result was small. Also, the huge data warehouse will bring out the exact outcome of the research. So, for example, after the detection of duplicate errors, the user will be awake to validate. Continuing the human validations may result in the other human efforts, which will be in the data warehouse. This figure 1 explains the open user involvement based on the data cleaning process. It will be the first process of the DC and it extended by the propagation step which responsible for the feedback of clean data to be operational user in order to validate them. So figure 2 explains that the second process of extract the transform load, which is the ETL. It is similar to the classical ETL process, but this is extended by the step for cleaning data at the operational data sources, which will be independently of the rest of steps. It can be performed before the ETL in order to improve the data at the operational data sources and then reduce the timing consumptions. It will be useful in the term of reduced timing. Okay, so there are the certain problems that has been identified in this approach. It can be realized that some enormous data requires manual intervention and other require the combination of manual and automatic data cleansing approaches. Data warehouse project mostly integrate the data quality phase into the extract transform load process, but not do not allocate the enough time for efficient data validation with respect to data cleansing. Also, when data has been extracted from operational data sources, feedback of data cleaning result is not considered, even though it is important to avoid redoing the same data cleaning process. This is all being covered in the open source environment done by the author. Next, I'll be handing over to the Nick to present the next slide.
Thanks, Rohini. So now I'm going to be talking about a paper called Data Cleaning Problems and Current Approaches by Aaron Ram and Hong Hai Do. Ram and Do covered the importance of data cleaning, common approaches, and common problems in this paper. It was a very important and influential paper when it was published in 2000. They covered a plethora of single sourced and multi sourced cleaning problems and solutions in a bunch of different tables that were all presented in this paper. The approaches that they advocated for included manual data analysis from a person, transformation workflows and mapping rules, as well as data verification, data transformation, and backflowing cleared data. They advocated for solving all of your single sourced issues before addressing any of the multi sourced issues in order to not create further problems down the line. When trying to solve multi sourced issues, they advocated for specifically a declarative query and mapping language for the schema related transformations and cleaning steps, so everything was clearly outlined. The problems they defined are still common issues that we see in data cleaning today, and the approaches that they discussed in this paper include valuable insights for cleaning crowdsourced data and other types of data that we're seeing as common issues now. And the main approaches they discuss define a workflow for cleaning the data, and the steps in their process are generalizable to crowdsourced data and big data and other types of data that we see now that weren't as relevant back when this paper was published in 2000. And many of the issues discussed today are similar enough to where you can extrapolate their form and their generalizable workflows to these problems. So the next paper is preparation of name and address data for record linkage using hidden Markov models. So Churches and the colleagues presented an alternative to rule-based approaches to data cleaning. This approach utilizes lexicon-based tokenization and probabilistic hidden Markov models, also known as HMMs. An HMM is a probabilistic finite state machine consisting of a set of observation symbols and a finite set of discrete observed states. A matrix of transition probabilities between those states and a matrix of the probabilities with which each state emits an observation symbol. The HMMs produce equal or better standardization accuracy than widely used rule-based systems. However, the accuracy is worse with simpler name data, so they primarily recommended using this with more complex name data. The data is first tokenized, and then a greedy algorithm is used to find a match within a lookup table. And then the data is run through the HMM, and each tokenized input acts as an ordered sequence of observation symbols for the state machine. And then this paper was rather revolutionary when it was published in 2002, because rule-based data cleaning was really the standard at the time. And HMMs have been used in many different data cleaning systems, including ones that are used currently today. HMMs were a pretty novel idea for data cleaning at the time, but they've become one of the more popular staple technologies for data cleaning since this paper. And the next one I want to talk about is a paper on Febril, which is an open source data cleaning, deduplication, and record linkage system with a GUI. Febril is a tool that's used for matching entities across a database. It was specifically designed for the medical industry, and all of its functionality is available through a GUI, which at the time was pretty rare back in 2008. It was the only tool of its kind during this time that was not proprietary. All other tools were impossible to analyze due to them being in proprietary black box solutions. In addition, Febril was written in Python, making forking the source code very accessible and also making it very easy to read for people who aren't as experienced. Febril allowed for data cleaning of names, dates, addresses, and phone numbers using a rule-based approach. It also utilized hidden Markov models, though, for cleaning more complex names, as we discussed previously. This came out a couple years after that previous paper we were discussing. And so some of those complex names, you might be asking, what does that mean? So, that could be more than one family or given name, or hyphenated names, or names with maybe complex characters. And complex names were a pretty big issue back in 2008 because rule-based approaches had been shown to not really be scalable for complex name data. But Febril's use of these hidden Markov models to clean the complex name data was, it was one of the first applications and the only one at the time that was publicly available open source to use these features. So it was pretty advanced. And its hybrid use of the classical rule-based with the hidden Markov models provides an interesting look into the advancements in data cleaning from this time period. You can kind of see this transition of some of the technologies emerging and then going into use. And most of the solutions at the time were proprietary, and they focused on, mostly rule-based approaches, while Febril was, supporting more advanced options in their data cleaning while also being a free open source piece of software. So now I'm going to hand it over to my group mate, David.
Uh, Development and user experiences of an open source data cleaning, deduplication, and record linkage system was a paper that was also about the Federal tool that was just discussed. And the first half of the paper so went into detail again over the same tools that Federal uses and how it works. But then it dives into a survey that was conducted amongst users of Federal. After sending out the survey, they had 22 respondents, and this is what they found out about who was using the tool. So, of those respondents, 27% were in industry, 18% were in government, and 55% were in academia. So, this shows that this open source tool had made its way into all sectors by 2009. The most common positive feedback was that this tool helped others in the field conduct their own research faster since it's not a black box system. So, at the time of the survey, this was still the only known open source tool available for doing these data cleaning techniques. And so, other people doing research that were using large data sets that needed to be cleaned, but data cleaning wasn't the focus of their research, they were able to use this tool in their own research to skip having to develop all of that technology themselves and still publish their research since they were able to explain how the tool was doing what it was doing. So that was the biggest reason that people were choosing to use this tool. In fact, 77% of its users said that the whole reason that they chose to use Federal was because of this and because it was open source. And so by skipping the step of needing to develop this tool themselves when doing research, this is kind of a form of automated multidiscipline research. And it allows for this sort of thing to happen easier. Um, so since the tool was open source, it took a larger effort to develop and it takes more time to make something like that. However, creating something that has so many features that have helped advance research in other fields proves that it is a necessity to have tools like this. Next slide. Data cleaning for data quality is another tool that was developed by a different group. It was also a software with a GUI where users would create their own rules on this platform by selecting options or data cleaning techniques that they wanted to perform on their input data source. And then those would be applied to the source. Then a decision tree induction would be performed on the data, and it would be the decision maker for how values in the source would be repaired or filled. The paper discusses the method in which the tree is developed in order to reduce the number of records that are deleted. So if all of the attribute values are missing on a record that comes in, they're all replaced by the most common values present for each of those attributes. Otherwise, the record will begin to go through the tree where the root of the tree is the attribute with the highest information gain on a record. And it goes from attribute to attribute through the tree, and any records that are that do have blank attributes will follow whatever the rules were selected by the user and fill in those blank values. Although this tool did seem to work functionally, there were no results on what the quality of the output of this system was. The group did not use a data set that was large enough that would allow for it to be uh, ranked in its quality accurately, but it was a good idea of an implementation of a tool that would help other people select how they wanted to clean their data. And now I'll hand it back over to Eric.
Thank you. So in this paper, Data Cleansing Techniques for Large Enterprise Data Sets, it goes over a data cleaning framework that combines three different tools: a synonym finder, a variant finder, and the RDR framework. RDR, or Ripple Down Rules, is a framework where rules are organized in a tree structure. The most generic rules are set as the roots of the trees, and discovered exceptions are added as branches. The variant finder looks at cases where there are multiple service forms of the same. For example, there are multiple ways to represent United States, either US or U.S or just United States. The synonym finder is where there are different service forms with the same semantic meaning. For example, there could be many terms for a religious building. How the system works is that when a database is going through the standardization process, the RDR framework would first check if the data point can be handled by the current rule set. If it cannot, then the variant finder and synonym finder algorithm will then attempt to find the correct form to convert the data to. If that's successful, then a new rule is created as a child of the initial rule, which is then used to catch similar future instances. This way, we have a continuously growing rule set that could learn and clean data as more data is presented. However, this paper only validates this framework against a relatively small set of data. Reading in between the lines, it implies that as data sets become large enough, they may struggle as new rules are constantly being created. Next slide. This paper, a data cleaning method on massive spatial temporal data, seeks to demonstrate a scalable method to identify and eliminate records that do not fit within a correct time frame. Many of the records collected from crowdsourcing have a spatial or temporal component. How it does this is by a two-step process. First, the raw data goes through time-based clustering, which is done as a Hadoop MapReduce job. The map task would be to find the beginning and end time steps, and then the reduce task would take the intermediate key value pairs generated from the map and create a date range distribution. After finding the temporal range, another map task would apply rule-based filtering to clean records that don't fit. Because of Hadoop's parallelism, this method scaled extremely well with extremely large data sets. However, it still does require rules for filtering, which means that there has to be a database engineer that's required to develop and maintain the rule-based system. However, because it does use Hadoop, this technique worked very well with crowdsourced data. Next slide. In this final paper, regarding specifically for data cleaning of enabling smart data, noise filtering, and big data classification, it proposes a framework in Apache Spark to remove noisy examples. Again, like the previous paper, this framework is composed of two algorithms. The first algorithm is a homogeneous ensemble called HME-BD, or homogeneous ensemble for big data. And it uses Apache Spark's random forest decision tree classifier to find misclassified data points. It functions by first partitioning the data into equal subsets. Then for each partition, it takes a segment of the data to train a random forest model, and then applies that model to the rest of the data to create the initial test data. Then that predicted test data is mapped back to original data, and if there's any differences in class, those are marked as noise, and then subsequently eliminated. The second algorithm is a heterogeneous ensemble called HTE-BD, which uses a set of 3 learning algorithms to identify mislabeled instances in a data set. It uses Spark's implementation of random forest, KNN, and logistic regression as learning algorithms to predict whether each data point is noise. Afterwards, the test data is mapped to the original data, a voting strategy is applied, and each instance is marked as noisy or clean. Both the algorithms proposed in this paper are based on already existing algorithms. However, the novelty is to use Apache Spark's specific implementation of several classification algorithms to focus on noise filtering for big data domains. And it does provide valuable insight in applying current machine learning algorithms for cleaning large data sets. As we go to the next slide, now I'm going to talk specifically about data transformation techniques. Next slide. Like what Nick presented earlier, hidden markup models were one of the earliest methods developed to automatically do data cleaning without rules, complex rules systems. Churches followed up the paper that Nick presented earlier called probabilistic name and address cleaning and standardization with the actual implementation of HMMs to solve data cleaning problems. It seeks to do that by first training an HMM with a training set to learn how to understand specific types of data points. Then, after initial cleaning to segment out the parts of the record, the HMM can determine probabilities of what each segment should be based on the previous segment. Using those probabilities, the system can determine what the record most likely is in a standardized format. And then, because it can standardize the data's records, it can now prepare them for data linkage. At the time of this paper, HMMs were considered to be have high potential to clean data automatically and are still in use. Next slide. In this paper, mining reference tables for automated text segmentation, it describes an automated method to segment unstructured data records by using data warehouses with large amounts of similar data as reference tables instead of having to write complex rules. Information in unstructured text needs to be properly segmented in order to be stored in a way that can be queried and analyzed. In this paper, the first step is to have an attribute recognition model to be built over each column of the reference table to determine the probability that a substring belongs to that column. Then a segmentation phase is run where input strings are split into constituent values and then compared to the possible attributes. Each segment is then assigned to columns where the quality of the segmentation has the highest probability given all possible segmentations. This way, you could use the reference table to save time and as a reference to automatically segment out the data and transform it into a usable format. While this paper does demonstrate that the system has improvements in robustness, effectiveness, and scalability against other segmentation systems, it does assume that not only do the reference tables have to exist, but those tables contain enough records to achieve a high segmentation accuracy. Thankfully, there are many data warehouses that currently exist that can be used for reference. Next week. Finally, the last paper I'm going to be discussing in this section is a grammar-based entity representation framework for data cleaning. In this paper, it seeks to reduce data duplication by using a framework to normalize data for easier record matching. It does this by using a programmable module that can transform data by using a generative grammar defined using context-free grammar rules. The grammar can be implicitly generated by database-style queries, large existing domain knowledge, like Wikipedia, Wiktionary, or DBLB. By pulling from these external sources, we can use a partially expanded grammar and reduce the size of the program to improve scalability. In cases where a record has multiple possible transformations, the grammar weights each variation to find the most likely form, and then doing this, we could transform it into a usable manner. Unfortunately, this paper is largely theoretical, and the paper itself states that it requires greater mean testing than what is described. Also, this framework requires a user to select the correct domain to generate the grammar, as well as use an appropriate algorithm for string matching. However, by using currently existing large data warehouses, we're able to circumvent many issues from creating complex rules. Next slide. Next, I'm going to hand it off to talk specifically about papers regarding crowdsourcing.
So now we're going to be getting into crowdsourcing, both crowdsourcing to obtain data and then the cleaning of that data so that it can be used in applications. So to start with that, we're going to go over data cleaning, overview, and emerging challenges. This paper mainly focused on what some of the challenges working with crowdsourced data would be as time goes on. This was published in 2016, which was towards the earlier end of when crowdsourced data was beginning to be researched. So it breaks all of data cleaning into two phases. The first is error detection, and the second is error repairing. So error detection includes detecting errors or anomalies because the system needs to know what to detect, how to detect it, and where to detect it. And then error repairing is the actual act or phase where that data that has errors is adjusted or removed to match whatever the requirements are for the data warehouse or application that the data is going to be going to. So some of the upcoming challenges to working with crowdsourced data that was addressed by this group are scalability. So scaling data cleaning techniques that are currently used to accommodate rapidly growing data sets has proven to not work as well as they have on smaller data sets. And so that's something that needs to be researched further, how the current techniques can be scaled to work with large data. There's user engagement now, so being able to repair integrity constraint violations during data cleaning is yet to be explored as more and more personal information is collected by different companies. Um, Semi-structured and unstructured data, the amount of data collected in semi-structured formats is not inconsequential, and that's the root of many data quality problems, especially when you could have multiple sources or in crowdsourcing, many sources of data coming into your system, and each of them could be using a different unstructured data as its input. New applications for streaming data. So there are estimates that in the early 2020s, there are going to be over 26 billion devices connected to the Internet of Things network. In the past, data collected by devices like this, which is just a constant stream of information, was mostly cleaned using quantitative techniques such as detecting outliers in the data. But with so much more data being collected all the time, new future work is going to be exploring how qualitative techniques can be worked and used on these data streams instead of just using quantitative approaches. And then there's privacy concerns. So data cleaning involves reviewing raw data, and more companies are collecting your data. And so being able to make sure that anything that's could be consequential to an individual person is not getting itself into the wrong hands. Next slide. So here's a group that wrote Crowdsourced Data Management Overview and Challenges, and they broke down this problem into a little bit more of a specific subsets. So when collecting data through crowdsourcing, three things that you need to take into consideration are latency, cost, and quality of that data. So there are different techniques for crowdsourcing that focus on either latency control, cost control, or quality control. Quality control are things that are done to get the highest quality data possible when crowdsourcing. As many errors as possible need to be caught, and the system needs to be able to infer high quality results from noisy inputs, such as semi-structured or unstructured data. This is tough because it requires more human analysis or very specific tuning of rules for each source of the data that's coming in, and that can take a lot of time and money. Cost control functions are focused on keeping the cost of the system down for crowdsourcing data. Using humans to help clean data is a costly task. This cost can be reduced using methods such as pruning to remove data cleaning tasks on the data source that have the lowest impact, with the goal being that it will take less time to review the clean data then. And then there's latency control, which focuses on reducing the latency as much as possible, so getting the data cleaned as fast as possible. Like quality control, this tends to be a bit inverse with the cost control approaches. Ways to reduce latency are to pay human workers more or hire more human workers to get it reviewed faster, or developing more sophisticated models for each of the input sources so that the rules that apply to each source of the data are more specific and tailored to where they're coming from so that there's less errors across the board. These are all problems that have kind of been introduced specifically with crowdsourced data, because when you have a very small data set, it's easy to kind of optimize all three of these factors. But as a result of not being able to easily maximize all three of these items with crowdsourced data, There are definitely upcoming challenges to crowdsourcing, including handling big data and privacy, query optimization, benchmarking, and other tasks. And that's because the guarantee of data quality that is the output of these systems is going to be smaller than it is when we do these techniques on small data sets. Next slide. So how do we start to solve these problems that are introduced by crowdsourcing? Many groups have started to develop tools that can be used specifically for cleaning and transforming large data sets. So some organizations, one of the big obstacles for them when cleaning big data is that when you have so many more sources, as I've said, there's a wider variety of data that could be collected. So if you don't have a very strict structure on what the data input is to where it's all being collected into, then there's lots of variations of what that data could look like. And with how much data there's very little time for experts in whatever the field is to review the clean data to verify the quality of it before it moves into the data warehouse or application. That's the endpoint for it. So some of the tools that have been implemented for crowdsourcing and cleaning that data are Kleenex, Scare, Katara, and Big Dancing. For example, Kleenex is a parallel big data cleansing system that addresses abnormal value detection, incomplete data filling, deduplication, and conflict resolution. So by working on the same data set in parallel, it first reads data from the global storage onto whatever the local machine is. Then it corrects it if it's abnormal. If there's any missing data, it'll fill that in. And then whatever the record is at that point, it'll update the global value for that record and then make sure that there's no deduplication in the global record if possible. So this cleansing is a little bit more fast paced because you're able to offload the cleansing onto many computers. And because of the rules that the system uses for cleaning, there's no need for a domain expert to review the data because the user is able to set up the rules for how abnormalities and missing values are dealt with. However, that does make the quality of the output data questionable. It's not going to be as reliable as data that is reviewed by a domain expert, where it's not just an automated set of rules filling in the data. One of the other examples here, Big Dancing. So they focus on improving the efficiency, easy use, and scalability for big data sets. And they do a very similar approach to Kleenex, where they allow a user to create rules for cleaning the data and then using parallel data processing frameworks that are already existing. They apply the rules to that data, and in the same process, they will upload the global record set with whatever the cleaned data is that they came up with. And again, although this eliminates the need for a domain expert, it does bring into question the quality of the clean data. Next slide. Another approach to handling crowdsourced data is the approach taken in research and engineering practice of emergency geographic information collaborative service mode with crowdsourced data. So a group in China has implemented and used crowdsourced data in an application, and they were able to eliminate the need for an expert to review the data by making a required structured data set as the input to their system. So what they were able to do is they created an application, which was the only source of submitting data to their system. And to submit data to the global record set, it had to match the structure, and all of the values had to be valid before they could be admitted. And so the application in China was for detecting and helping people navigate natural disasters such as forest fires. So when there's a forest fires going through China, people are able to alert others when they see where one is or how fast they're moving and things like that. And so that data then goes to the goes through the network to the structured data global record set, where it's then put into their platform that other people are able to look at and analyze what everybody else is saying about where the natural disasters are occurring. And then other agencies such as the government or rescue services are also able to interact with that platform and go and take action to address the natural disasters and help however they can, wherever they can. So this was a really cool implementation from this group because it allowed for an application using crowdsourcing to be quickly developed and implemented, and actually used to help people without needing to worry about what the quality of the data is, which could make it make the application not work. Next slide. So next, Rohini will take over and discuss other crowdsourcing tools.
All right, I'm going to actually take over on this one. So Chu and colleagues created a system called Katara, which had three modules, one for pattern discovery, pattern validation, and one for data annotation. The pattern discovery module is able to take in tabular data with an unknown schema, and it looks for patterns and relationships in that data, and then that output is sent through their p-discovery algorithm, which is able to retrieve table patterns with a very high accuracy without needing to enumerate through all of the data again. The output of the pattern discovery module then goes to the pattern validation module, which utilizes crowdsourcing to validate patterns generated in the pattern discovery module. It generates a large amount of questions that can be understood by an uneducated crowd worker. These questions ask crowd workers to verify types of columns and giving them a snippet of data with multiple choices that they can list for the different types. And it does the same thing with relationships. It gives them a small snippet of data and then asks them to verify the relationship between two different columns. After the relationships and types are validated, the data goes through the data annotation module. It does this with more crowdsourcing. It generates more questions to ask the crowd with a small snippet of data. And then if it finds inconsistent results, the data is run through their data repairing algorithm and then further crowdsourcing. This system provides for an interesting solution to a problem of dirty crowdsourced data, which is, more crowdsourcing. By creating a system which can generate easily readable questions for an uneducated crowd, Katara makes the process of validating its data much more efficient. The main problem that can arise in this kind of solution is just the scalability, with data sets getting exponentially larger every year. It's hard to say at what point this won't be feasible. Moving on to the next one, Wisteria is a platform developed by Haas and colleagues, which is used to create workflows that are used for data cleaning. It uses a scripting language that they created with crowd workers in mind, with the goal to be easy to learn and understand. Once the workers have been, or once the workflows have been created, they can then be run and observed in real time. And the user executing the workflows can query snippets of data and how the cleaning process is going and kind of see how everything's coming along. This allows the user to alter the workflows and rerun without waiting for the entire data set to be cleared. Like Katara, this system utilizes crowdsourcing for data cleaning, but relies a little bit harder on the crowd workers to be trained and have more experience writing the workflows. The system also mostly uses a rule-based approach, which has its own limitations. And I'm going to be handing off to Rohini for this one.
Thank you so much, Nick. Here, in this research paper done by the Zhang and Hujun, proposed a manual technique for error detection, which is based on the crowdsourcing. This technique is beneficial in low-cost maintenance. Also, this paper mainly focuses on manual detecting the errors through crowdsourcing and goes over a technique that varies the number of answers per question, which is based on the how difficult it is to understand and to reduce the crowdsourcing cost. Consider, for example, most of the people know the color blue. So can answer the question about this color with high accuracy, but fewer people know about the color cyan. So we may want to ask the fewer question for involving the color blue, but more question that involves the color cyan. Here, the author of this paper have come up with a solution called VChecker, where they first obtain a ranking of the data regions in regards to the difficulty and then decide the number of answers it should have. Later, they demonstrate that with multiple examples, but not shared the deeply about how to partition the data into the multiple regions and how to rank the data into the regions and the difficulties. This figure shows that how iterative exploration is sensitive to varying these values. It shows that this process covers between the 3 and the 6 for all the three data sets. suggesting that the setting the values to 5 is a reasonable choice. In the current vchecker system, they set the x max equals to 5 and y max equals to 5, meaning that the iterative exploration in the process. Next. The cleaning system, which is based on the crowd cleaner done by the group of people. Here they have proposed an online data cleaning system called as the crowd cleaner, which is based on the crowdsourcing because it has the low maintenance cost, and it also has a better quality of data cleaning with the human efforts than automated process. As compared to the automated approaches, this will include the human efforts, also the low cost maintenance, the higher quality of the data. They propose the system which has a high accuracy but low cost, which will be the simpleness, flexibility, and the friendly user interface. They used only a small amount of data that are the most difficult to clean with automated approaches. So as a result, the cost will be the low and with a high accuracy. The crowd cleaner uses the human efforts to input the answers via the crowdsourcing to clean the dirty data. Here, the crowd cleaner is also capable to resolve the incompleteness, the inconsistency, and the conflicts of data. When crowd cleaner provides the user with interface, it will be act as an interface to upload the dirty data files and download the cleaning data files according to the different data problems. They have stated that with the help of example, consider the name cluster of city, animal, school on the web, because the data sources may contain the errors or inconsistencies. This paper used them as our experimental data. So points such as crowdsourcing, the task to be public platforms such as ATM may take long time and not suitable for demonstration. That they has been considered and developed a crowdsourcing platform special for data cleaning. Here, the system initially reads the user uploaded dirty data via the user interface, then scans the uploaded data for any incompleteness or inconsistency or if there are any conflicts. Once the dirty data has been cleaned with the help of automated cleaning, then the selected short data will be passed further for selection and crowdsourcing. Later, then with the help of answers from workers and the selection modules, final clear results will be released. With the help of entropy to filter the data for inconsistency and conflicts, they use the entropy on the fraction of tuples to calculate the score of records. Also, with the help of Bayesian network, missing attributes has been handled. And later, the results will be filtered with the calculated confidence degree of each answers according to the quality of works who provided the answers. With the help of answers from the worker, the selection of module final results will be released. So I'll be yeah.
So, in conclusion, there are several things that become clear after our literary analysis. Firstly, this is currently a very active field of study. There are still many challenges that need to be resolved, and since applying crowdsourcing to gather data is still relatively recent technology, new issues are constantly being discovered. Next, many of the data cleaning techniques that previously worked do not scale well when we reach the bounds of data that are now available. Several research topics discussed in this presentation show that the old methods either had too high a setup cost or took too long to clean data. Finally, most of the currently proposed solutions are application specific. Many of the tools spoken of in this presentation seek to provide general solutions that could solve the issues of data cleaning. Here are our references to the papers that we discussed in this presentation. Thank you all for listening to us talk about data cleaning.